Last video, we talked about how C++ allows us to create user-defined types. To do this, we use a C++ concept called a class that allows us to associate data and related functionality into a single object. The sample object we're going to use, our first user-defined class, is going to be a cube. Let's see how this works. The big idea of a user-defined type in C++ is the idea of encapsulation, and I think of this as a pill. Something you might take, and inside this pill, you have both data and you have functionality. And we're going to separate the data from the functionality and talk about them individually. Thinking about our sample cube, the data associated with the cube might be something like the length of one side of the cube. And then functionality we might talk about at the cube is going to be getting the volume of the entire cube, which would just be the cube of the length. So in the data side of the pill, I'm going to go ahead and add the variable length. And I'm going to follow Google's style guide. When we have private member variables of a class, I'm going to add an underscore after that variable name just to let us know it's a private member variable, and we'll talk about that more in detail shortly. Functionality, we're going to have a function called getVolume. And here we've encapsulated both the private member data as well as the getVolume function inside of our capsule. And this is the idea of encapsulation. Our class is going to include both that data and the functionality. I mentioned private member data as opposed to just member data, and the one thing that we missed in the pill earlier is that the pill is both divided into functionality and data as well as into protection layers, both private data and public data, private functionality and public functionality. These layers of protection determine who can access what elements of our class. When we have data that's public, that data can be accessed by anyone. Anyone who uses our class, which we're often going to call client code, is any code that imports our class and makes use of our cube or whatever custom data type we have. If a member function or a member data variable of our class is public, anyone can access this. The other side of protection is if we declare any of our variables or any of our methods private, that data or that functionality can only be accessed by the class itself. The second idea of encapsulation is when we actually write the source code to implement all of this. We're going to write the source code in two separate places. There's going to be a header file which defines the interface to the class, and an implementation file that defines the actual code to run our class. So let's start in taking a look at the header file first. Again, the header file is simply an interface to the class, and it includes the declaration of all of the member variables and the declaration of all of the member functions. But it does not include the implementation of those functions. So what we expect in a header file is going to be something akin to an API, where we're going to define exactly what programmers can call in our class and exactly what our class stores, but not how those things work. Let's go ahead and build ourselves a header file for the cube. Again, here in the CPP class directory, we have cube.h, and in this cube header file, we're going to see our very first header file. And I want to point out 4 different features of this header file. The first thing is the very first line of code in the header file is going to be the line of code pound pragma once. This line of code is always present in H files or header files. This pragma once line instructs the compiler to only compile this code once. Even if multiple people use our class, we'll only want the definition of our class to be defined exactly once. The second thing to note is the syntax we use to declare a class in C++. Here you see the keyword class followed by the name of the class itself. So here we have class cube, and followed by the name of the class, we have a curly brace that defines the scope of the class. The last thing to notice about this is the class always ends with a semicolon. The third thing to note is there are 2 different protection regions in the class, and all of the variables and functions are defined within those protection regions. On line 15, you'll see we have the public protection region, and on line 20, you see we have the private protection region. In the public protection region, everything following the public declaration before the private declaration are public variables or public functions of this class. Everything following the private label are private variables or private functions in the class. In this class, we have 3 private functions. We have getSurfaceArea, getVolume, and setLength. we have only one private variable in this class. That private variable is length. Notice in this H file, we have not defined how getVolume works, how getSurfaceArea works, or how setLength works. All we've done is declare that these are the functionalities of the class. We need to look at our CPP file to find out how they actually work. In the CPP file, we call this file the implementation file, and it's the code that contains all of the logic to implement our class. Let's take a look at this. In the class CPP file, we've got, again, 3 different areas that we want to look at. The first is we have a pound include that includes a reference to our header file, and then we have the implementation of our 3 functions that were defined in our .h file. The only difference in the definition of these functions from where we saw in the .h file is these functions' name needs to include the name of the class where they're defined in. Here on line 10, we have double cube, : getVolume. This means we're going to define the implementation of the cube's getVolume function. And cube's getVolume returns the length times the length times the length, which is the volume of our cube. GetSurfaceArea is the same idea. We have a double getSurfaceArea. It's part of the cube class. We define it as 6 times the square of the length. And setLength takes a parameter in, double length, and sets that parameter equal to the private member variable length. So setLength is going to update our internal variable length to be equal to the variable that got passed in. Now that we understand how this cube class is built, we can go ahead and build a program using our cube class. To do that, we're going to need a main function, the starting point of all C++ programs, and we're going to need to include the cube.h header file so the C++ compiler can know what a cube object is. You'll see we've included the header file on line 10. We have main on line 12. We declare a new cube on line 13, and then we're going to go ahead and set its length equal to 3.48. I'm going to go ahead and define a variable volume that gets the value of C, our cube's volume. Again, calling that getVolume function that we defined in our cube. And on line 17, we finally see out, or console out, the volume of our cube. So we expect this program to create a cube in memory on line 13, set the length of one side of his cube to 3.48, and then we expect volume, another variable, to be equal to 3.48 times 3.48 times 3.48, which is approximately equal to 42. So the output then is the word volume, followed by the number 42. So this is exactly what we expect. Let's go and compile this code and see whether or not we get the results that we expect to get from reading over the code. The code for this video is in the directory cpp class, and then I'm going to run make to compile this code. Once this code compiles, I run /main to run it, and we see that the volume is 42.1442. This is exactly what we expected from the code we looked at on the slides. Awesome. You just saw your very first CPP class, and you were able to make a custom object inside the C++ language. We're going to keep using this cube and learning more about how this cube works inside C++ in the next video. I'll see you there.